Muted. Greetings and salutations. This is Carl Seward, instructor of mathematics and statistics here at the Arizona College of Nursing, Falls Church campus. This is one of the questions that I referred to your midterm exam review as, hey, come check out the video. Come see Carl Seward's video on his YouTube page. So if you're listening to this, that means you have the link to my YouTube page. And I want to go over question 14. It says, which set will have the larger standard deviation? Set 1 or set 2? What does this mean? This means, friends, you actually have to calculate the standard deviation of both of the quantities. So there's no other way to get around it. You have to calculate the standard deviation of both quantities. So what I'm going to do is I'm going to hit the pencil and I'm going to do the standard deviation of set 1. So let me pick this color. So with set 1, we know the numbers are -3 rather, 5, 6, 8, and 9. You'll remember in class what we did, created a chart of X, created a chart of X minus X bar, create a chart of X, and let me make that X minus X bar chart a little wider because it need some space. And then I'm going to say X minus X bar squared. And then after I do that, I'll be able to utilize that in the formula for the standard deviation, assuming that this is a sample, and that'll be over n minus 1. And then that's the square root of the sum of the variations squared minus or divided by n minus 1. So in doing so, this is, I gotta calculate what my mean is. So up here in the top right hand corner, I'm gonna do this work on the mean. So I'm gonna say -3 plus 5 plus 6 plus 8 plus 9, all divided by 5. You can pick up your handy dandy calculator. -3 plus 5 plus 6 plus 8 plus 9 is 25. And 25 over 5 is equal to 5. And that arrow, this equal sign with the arrow, that means implies. So 25 divided by 5 implies that it's going to be equal to 5. So now this is -3, this is 5, this is 6, this is 8, this is 9. This is going to be -3 minus 5. This is going to be 5 minus 5, 6 minus 5, 8 minus 5, 9 minus 5. Going back up here, -3 minus 5 is -8. 5 minus 5 is 0. 6 minus 5 is 1. 8 minus 5 is 3. 9 minus 5 is 4. And if I add these all up, I will get this. And then I have to square those. Squared, 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 squared. Make sure I lay like 2s. And so therefore, I have 64, because that's -8 times -8. Goose egg, because 0 times 0 is goose egg or 0. 1 squared is 1. 3 squared is 9. 4 squared is the same as 4 times 4, which is 16. And now I'll be able to take the sum of my deviations squared. So that'll be 64 plus 0 plus 1 plus 9 plus 16 And in so doing, you'll get 90. So I know that this is going to be the square root of 90 over in I have 5 pieces of information, 5 minus 1. So the standard deviation would be the square root of 90 over 4. 90 divided by 4 is going to be 22.5. And then the square root of 22.5 is 4.74. I've decided to round 2 places after the decimal. So I know that's for set A. Let me see if I can change the color. Where's the palette? I'm going to see it here. So we know for set 1, the standard deviation is 4.74. 4.74 approximately. Let me make sure that means 4.74 for set A. That's the work. You may want to pause to copy this work, to understand this work. So feel free to hit the pause button. I'll give you a countdown to maybe 5 seconds, and then I'm going to continue, but feel free to pause and then unpause. For those of you guys that are ready to begin, let's look at set 2. In order to do set 2, let's see if I have enough space down here. I do. So set 2 is going to be -3, 7, 12, 18, and 21. Same script, different cast. I'm going to make my columns. X minus X bar. Give myself a little bit of space. X minus X bar squared. And then I'll be able to get my answer. So I have -3, 7, 12, 18, and 21. I need to find out what the mean is. So I do that in. So that's -3 plus 7 plus 12 plus 18 plus 21. That's over 5. So then I would have -3 plus 7 plus 12 plus 18 plus 21, 55. So I have 55 over 5. 55 over 5 is 11. So that means my mean is 11. I'm going to give this thought cloud because I'm not finished all my work. I like giving boxes around my work, thought clouds while I'm in the process. So now I'm going to just change the color for clarity. -3 minus 11. 7 minus 11. 12 minus 11. 18 minus 11. 21 minus 11. And if you notice, scholars, I write out the arithmetic before I actually do the arithmetic. I'm not trying to move too fast. It'll be okay. So here, I know that -3 minus 11 is a -14. 7 minus 11 is a -4. 12 minus 11 is 1. 18 minus 11 is 7. 21 minus 11 is 10. So then I'm going to take those numbers and square them. Run all my work, and then I'm going to do my arithmetic. So -14 squared is 196. -4 squared is 16. 1 squared is 1. 7 squared is 49. Make sure you have good handwriting, better than 9. And then 10 squared is 100. Change my color back. So now I know I can get the sum of my deviations squared by adding 196 and 16 and 1 and 49 and 100, you get 362. So in my formula for standard deviation, assuming it's a population, I have the top, 362, and then it's n minus 1. So 5 minus 1. Move that here. So S is equal to the square root of 362 over 4. 362 divided by 4 is 90.5. The square root of 90.5 is going to be, rat-a-tat-tat, drum roll please, 9.51. And there you have it. So then if I know that maximum poles, if you need to see the work for set 2, this was set 2. And then you will see that for set 2, it's bigger than set 1. So the answer is, which set will have a larger standard deviation, set 1 or set 2? You know what the answer is. The answer is set 2. Just wanted to help you out with that standard deviation.